Hello friends, welcome to my YouTube channel 12th School Zone. இன்னைக்கு நம்ம இந்த வீடியோவில் கிளாஸ் 12 Physics Reduced Syllabus 2021-22 தான் பார்க்க போகிறோம். இப்போ நம்ம என்னென்ன இருக்குன்றதை நான் சொல்லிடுறேன். Chapter 1 Electrostatics, அதில் 1.1 Introduction, 1.2 Historical Background of Electric Charges, 1.1.2 Basic Properties of Charges, 1.2 Coulomb's Law, 1.2.1 Superposition Principle, 1.3 Electric Field and Electric Field Line, 1.3.1 Electric Field, 1.3.2 Electric Field due to a system of point charges, 1.4 Electric Dipole and its properties, 1.4.1 Electric Dipole, 1.4.2 Electric Field due to a dipole, 1.4.3 Torque experienced by an electric dipole in the uniform electric field, 1.5 Electrostatic Potential and Potential Energy, 1.5.1 Electrostatic Potential Energy and Electrostatic Potential, 1.5.2 Electric Potential due to a point charge, 1.5.3 Electrostatic Potential at a point due to an electric dipole, 1.5.6 Electrostatic Potential Energy for collection of point charges, 1.5.7 Electrostatic Potential Energy of a dipole in a uniform electric field, 1.6 Gauss law and its application, 1.6.1 Electric flux, 1.6.2 Electric flux for closed surfaces, 1.6.3 Gauss law, 1.6.4 Applications of Gauss law, 1.8 Capacitor and Capacitance, 1.8.1 Capacitors, 1.8.2 Energy stored in the capacitor, 1.8.3 Application of capacitors, 1.8.4 Effect of dielectrics in capacitors, 1.8.5 Capacitors in series and parallel, 1.9 Distribution of charges in a conductor and action at points, 1.9.1 Distribution of charges in a conductor, 1.9.2 Action of points or corona discharge, 1.9.4 Van de Graaff generator. இப்போ நம்ம chapter 2 பார்க்கலாம். Chapter 2 Current Electricity Introduction, 2.1 Electric Current, 2.1.1 Conventional Current, 2.1.2 Drift Velocity, 2.1.3 Microscopic Model of Current, 2.2 Ohm's Law, 2.2.1 Resistivity, 2.2.2 Resistors in series and parallel, 2.2.3 Color code for carbon resistors, 2.2.4 Temperature dependence of resistivity, 2.3 Energy and power in electrical circuits, 2.4.1 Electromotive force and internal resistance, 2.4.2 Determination of internal resistance, 2.4.3 Cells in series, 2.4.4 Cells in parallel, 2.5 Kirchhoff's rule, 2.5.1 Kirchhoff's first rule, 2.5.2 Kirchhoff's second rule, 2.5.3 Wheatstone's bridge, 2.5.4 meter bridge, 2.5.7 measurement of internal resistance of cell by potentiometer, 2.7 thermoelectric current, 2.7.1 Seebeck effect, 2.7.2 Peltier effect, 2.7.3 Thomson effect. Chapter 3 Magnetism and magnetic effects of electric current, 3.1 Introduction, 3.1.2 Basic properties of magnets, 3.2 Coulomb's inverse square law of magnetism, 3.8 Biot-Savart law, 3.8.1 Definition and explanation of Biot-Savart law, 3.8.2 Magnetic field due to long straight conductor carrying current, 3.8.3 Magnetic field produced along the axis of current carrying circular coil, 3.8.5 Current loop as a magnetic dipole, 3.9 Ampere circuital law, 3.9.1 Ampere circuital law, 3.9.2 Magnetic field due to a current carrying wire of infinite length using Ampere's law, 3.9.3 Magnetic field due to a long current carrying solenoid, 3.10 Lorentz force, 3.10.1 Force on a moving charge in a magnetic field, 3.10.2 Motion of a charged particle in a uniform magnetic field, 3.10.3 Motion of a charged particle under crossed electric and magnetic field velocity selector, 3.10.5 Force on a current carrying conductor placed in a magnetic field, 3.10.6 Force between two long parallel current carrying conductors, 3.11.2 Moving coil galvanometer. Chapter 4 Electromagnetic induction and alternating current, 4.1 Electromagnetic induction, 4.1.1 Introduction, 4.1.2 Magnetic flux, 4.1.5 Fleming's right hand rule, 4.1.6 Motional EMF from Lorentz force, 4.3 Self-induction, 4.3.1 Introduction, 4.3.2 Self-inductance of long solenoid, 4.3.3 Mutual induction, 4.3.4 Mutual inductance between two long coaxial solenoids, 4.4 Methods of producing induced EMF, 4.4.1 Introduction. 4.4.2 Production of induced EMF by changing the magnetic field. 4.4.3 Production of induced EMF by changing the area of the coil. 4.4.4 Production of induced EMF by changing relative orientation of the coil with the magnetic field. 4.6 Transformer. 4.6.1 Construction and working of transformer. 4.6.2 Energy losses in transformer. 4.6.3 Advantages of AC in long distance power transmission. 4.7 Alternating current. 4.7.1 Introduction. 4.7.1 Mean or average value of AC. 4.7.2 RMS value of AC. 4.7.3 AC circuit containing pure resistor. 4.7.4 AC circuit containing pure inductor. 4.7.5 AC circuit containing only a capacitor. 4.7.6 AC circuit containing a resistor, an inductor and a capacitor in series RLC circuit. 4.7.7 resonance in series RLC circuit. 4.7.8 Q factor. 4.8 power in AC circuits. 4.8.1 Introduction of power in AC circuits. 4.8.2 wattless current. 4.8.3 power factor. 4.8.4 advantages and disadvantages of AC over DC. 4.9 oscillation in LC circuits. 4.9.1 energy conversion during LC oscillations. 4.9.2 conservation of energy in LC oscillations. Chapter 5 Electromagnetic waves. 5.1 Introduction. 5.1.1 Displacement current and Maxwell's correction to Ampere's circuital law. 5.1.3 Maxwell's equations in integral form. 5.2 Electromagnetic waves. 5.2.1 Production and properties of electromagnetic waves, Hertz experiments. 5.2.3 Electromagnetic spectrum. 5.3 Types of spectrum, emission and absorption spectrum, Fraunhofer lines. Chapter 6 Ray optics. 6.1 Introduction. 6.1.1 Ray optics. 6.1.2 Reflection. 6.1.3 Angle of deviation due to reflection. 6.1.4 Image formed in a plane mirror. 6.1.5 Characteristics of the image formed by plane mirror. 6.2 Spherical mirror. 6.2.1 Paraxial rays and marginal rays. 6.2.2 Relation between F and R. 6.2.5 The mirror equation. 6.2.6 Lateral magnification in spherical mirror. 6.3 Speed of light. 6.3.1 Fizeau's method to determine speed of light. 6.3.3 Refractive index. 6.3.4 Optical path. 6.4 Refraction. 6.4.1 Angle of deviation due to refraction. 6.4.3 Principle of reversibility. 6.4.4 Relative refractive index. 6.4.5 Apparent depth. 6.4.6 Critical angle and total internal reflection. 6.4.8 Refraction in glass slab. 6.5 Refraction at single spherical surface. 6.5.1 Equation for refraction at single spherical surface. 6.6 Thin lens. 6.6.3 Lens maker's formula and lens formula. 6.6.4 Lateral magnification in thin lens. 6.6.6 Focal length of lenses in contact. 6.6.7 Silvered lenses. 6.7 Prism. 6.7.1 Angle of deviation produced by a prism. 6.7.2 Angle of minimum deviation. 6.7.3 Refractive index of the material of the prism. 6.7.4 Dispersion of white light through a prism. 6.7.5 Dispersive power. 6.7.6 Scattering of sunlight. Chapter 7 Wave optics. 7.1 Theories on light. 7.1.1 Corpuscular theory. 7.1.2 Wave theory. 7.1.3 Electromagnetic wave theory. 7.1.4 Quantum theory. 7.2 Wave nature of light. 7.2.1 Wave optics. 7.2.2 Huygens principle. 7.2.3 Proof for loss of reflection using Huygens principle. 7.2.4 Proof for loss of refraction using Huygens principle. 7.3 Interference. 7.3.1 Phase difference and path difference. 7.3. Coherent sources. 7.3.3 Double slit as coherent source. 7.3.4 Young's double slit experiment. 7.3.5 Interference in white light, polychromatic light. 7.3.6 Interference in thin films. 7.4 Diffraction. 7.4.2 Diffraction in single slit. 7.4.4 Fresnel's distance. 7.4.5 Difference between interference and diffraction. 7.4.9 Resolution. 7.5.3.1 Polarizer and analyzer. 7.5.3.2 Plane and partially polarized light. 7.5.3.3 Malus law. 7.5.3.4 Uses of Polaroids. 7.5.4 Polarization by reflection. 7.5.4.1 Brewster's law, 7.5.4.2 pile of plates, 7.6 optical instruments, 7.6.1 simple microscope, 7.6.1.1 near point focusing, 7.6.1.2 normal focusing, 7.6.1.3 resolving power of microscope, 7.6.1.4 resolving power of telescope, 7.6.2 compound microscope, 7.6.2.1 magnification in compound microscope, 7.6.3 astronomical telescope, 7.6.3.1 magnification in astronomical telescope, 7.6.5 reflecting telescope, 7.6.6.3 astigmatism. Chapter 8 Dual nature of radiation and matter, 8.1 Introduction, 8.1.1 Electron emission, 8.2 Photoelectric effect, 8.2.1 Hertz, Hallwalk and Lenard's observation, 8.2.2 Effect of intensity of incident light on photoelectric current, 8.2.3 Effect of potential difference on photoelectric current, 8.2.4 Effect of frequency on incident light on stopping potential, 8.2.5 Loss of photoelectric current, 8.2.6 Concept of quantization of energy, 8.2.7 Particle nature of light, Einstein explanation, 8.2.8 Photoelectric cells and their applications, 8.3 Matter waves, 8.3.1 Introduction, wave nature of particles, 8.3.2 de Broglie wavelength, 8.3.3 de Broglie wavelength of electron, 8.3.4 Davison-German experiment, 8.3.5 electron microscope, 8.4 X-ray spectra, continuous X-ray spectra, characteristic X-ray spectra. Chapter 9 Atomic and Nuclear Physics, 9.1 Introduction, 9.2 Electric discharge through gases, properties of cathode rays, 9.2.1 Determination of specific charge, E by m of electron, Thomson's experiment, 9.2.2 Determination of charge of electron, Millikan's oil drop experiment, 9.3.2 Rutherford model, 9.3.3 Bohr atom model, 9.3.4 atomic spectra, 9.4.3 atomic and nuclear masses, 9.4.4 size and density of nucleus, 9.4.5 mass defects and binding energy, 9.4.6 binding energy, 9.5 nuclear force, 9.6.1 alpha decay, 9.6.2 beta decay, 9.6.3 gamma emission, 9.6.4 loss of radioactivity, 9.6.5 half-life mean life, 9.6.6 carbon dating, 9.7 nuclear fission, 9.8 nuclear fusion. Chapter 10 Electronics and Communication Systems, 10.1 Introduction, 10.1.1 Energy band diagram, 10.1.2 Classification of materials, 10.2 Types of semiconductors, 10.2.1 Intrinsic semiconductor, 10.2.2 Extrinsic semiconductor, 10.3 Diodes, 10.3.1 PN junction formation, 10.3.2 PN junction diode, 10.3.4 Rectification, half wave rectification circuit, full wave rectification circuit, 10.3.5 breakdown mechanism, 10.3.6 Zener diode, 10.4 the bipolar junction transistor, 10.4.1 transistor circuit configuration, 10.4.2 transistor action in CB mode, 10.4.3 relation between alpha and beta, 10.4.4 operating point, 10.4.5 transistor as a switch, 10.5 digital electronics, 10.5.1 analog and digital signal, 10.6 Boolean algebra, 10.7 De Morgan's theorem, 10.7.1 De Morgan's first theorem, 10.7.2 De Morgan's second theorem, 10.7.3 integrated chips, 10.8 communication system, 10.9 modulation, 10.9.1 amplitude modulation, 10.9.2 frequency modulation, 10.9.3 phase modulation. Chapter 11 Recent Developments in Physics, 11.1 Introduction, 11.2 Nanoscience and Nanotechnology, 11.2.1 Nanoscience, 11.2.2 Interdisciplinary Nature of Nanotechnology, 11.2.3 Nano in Nature, 11.3 Robotics, 11.3.1 What is Robotics, 11.3.2 Components of Robotics, 11.3.3 Types of Robotics. இப்போ நம்ம தியரிக்கான ரெடியூஸ் சிலபஸ் பார்த்தோம். அடுத்து ப்ராக்டிகல்ஸோட ரெடியூஸ் சிலபஸ் பார்க்கலாம். Experiment number 1. Determine the value of horizontal component of the earth magnetic field using tangent galvanometer. Take at least 4 readings. Experiment number 2. Compare the EMF of two cells using potentiometer. Experiment number 3. Adjust the grating for normal incidence using spectrometer. Determine the wavelength of green, blue, yellow and red lines of mercury spectrum. The number of lines per meter length of the grating can be noted from the grating. Experiment number 4. Voltage current characteristics of PN junction diode. Experiment number 5. Verification of truth tables of logic gates using integrated circuits. Experiment number 6. Verification of De Morgan's theorems. Thank you friends. இதுவரைக்கும் நம்ம சேனலை சப்ஸ்கிரைப் பண்ணவங்க எல்லாருக்கும் தேங்க்ஸ். இன்னும் இது வரைக்கும் சப்ஸ்கிரைப் பண்ணாதவங்க பக்கத்தில் இருக்க பெல் ஐக்கானை ப்ரெஸ் பண்ண மறந்துடாதீங்க.